Here we see video help for performing gestures. Videos are not very engaging to watch and may not motivate users to expend the considerable effort needed to learn gestures. Here we see gesture play, a novel technique for teaching gestures. Here the user wants to learn the gesture named kangaroo and so taps on the command name on the toolbar on the left side of the screen. Unfamiliar with multi-touch devices, the user pokes furtively at the display, causing the widgets on screen to shake, drawing the user's attention. The user then tries using a single finger. However, this is the wrong posture, causing the contact pad to slip off their finger, producing an engaging and fun response using the physics engine. The user tries 2 fingers but moves in the wrong direction. On their next attempt, the user tries compressing the spring and successfully executes the gesture. At the top of the screen, a notification tells the user that a trophy has been awarded for completing this gesture. The user can collect all of the unique trophies available in the system by completing all of the gestures. The user plays around with the system for fun and also explores other possible variations of the gesture to see what is possible. To augment the expressivity of the spring metaphor, springs can be combined with physical props. Here the spring has been combined with a tire prop which can rotate about its center. The springs and props leverage a priori knowledge users have about the physical world. Physical props also add additional variety among the gesture puzzles without requiring the addition of an entirely new metaphor, since they still leverage springs. Springs can be augmented with feed-forward presentation of additional springs for teaching gestures that involve a change in pose or path partway through. A new spring and hand overlay appears via an intro animation as the user executes the gesture. Even though the user has already completed the gesture, they continue playing with the gesture puzzle for fun, executing a number of repeat performances of the gesture. To teach gestures with a static pose, we use a button metaphor. When the user presses the wrong number of buttons, the remaining ones light up, indicating they can be pressed. The user then performs the correct gesture by pressing all 4 fingers on the display. Here the user performs a pinch gesture, comprised of 2 contact pads connected by a spring. The user performs a 2-finger tap gesture, which has a timing element. This timing element is taught using the feed-forward mechanism. The user performs a 1-finger swipe gesture, comprised by a single spring. The user performs a hand swipe gesture, which takes advantage of a larger contact pad and a different hand overlay affordance. The user performs a static pose gesture, which takes advantage of large mitten-shaped buttons. The user performs a bimanual hand side swipe gesture, which uses 2 hand overlays, 1 for each hand, as well as 2 springs. The user performs a palm unfolding gesture, which utilizes a curved spring as well as a stationary prop which appears to be anchored to the display using 2 screws. The user performs a similar gesture that involves an additional element. The hand moves to the right. This is achieved by adding an additional spring to the set of widgets. The user performs a 5-finger crumple gesture, which involves 5 finger pads connected together with 4 springs. A hand overlay helps to disclose the initial posture. The user performs a bimanual whole hand gesture, which involves 2 large palm-sized pads connected to smaller thumb-sized pads with springs. A second set of springs illustrates the upward motion. The user performs a tap gesture with a single button. Finally, the user performs a static pose gesture, which involves a button that is shaped like the pose, coupled with a hand overlay. Thus we have seen gesture play, fun, positive reinforcement through game-like physical metaphors to motivate online gesture learning.